Hello my dear grade 8 students. So now we are about to start our 8th lesson in grade 8 science syllabus. So in the earlier lessons we studied about electricity, sound, magnets, and now we are about to discuss about the next lesson. So next lesson is all about the changes that can happen into matter. Changes that can be happen into matter. So before I'm going to start my lesson, I'm going to ask you a simple question. What kind of a thing is matter? What sort of a thing is called as matter? What are the things contained in matter? I mean, like we can divide matter into several parts or several categories. So what are those things? What are those categories of matter? So first of all, let's see what kind of a thing is called as matter. So my dear children, matter is a simple thing. I can say it can be anything, any kind of a thing, any simple thing that has a mass. That has a mass. You know that we can measure the mass by using kilograms or grams. In the earlier lessons, we studied that mass means the amount of substances contained in matter. So anything that has a mass is considered as matter. Anything that has a mass is considered as a matter. Not the mass, but if you take the space or the volume, matter is going to obtain a certain amount of volume or certain amount of space in a certain environment. So we can rephrase matter like this. Matter are the things that has a mass and which is going to occupy a certain volume or else a space. So those are the things which are called as matter. Anything that has a mass and anything that can occupy space. So any kind of a thing that has a mass and which can occupy space is called matter. So we have divided matter into three main categories or three main states. Those three states are solids, liquids, and gases. Solids, liquids, and gases are the three main categories or the three main states of matter. Any kind of a solid, any kind of a gas, any kind of a liquid is going to belong to the thing called matter. So we'll be discussing within this lesson what kind of a change can matter take. What kind of a change will matter is going to perform when they are subjected to several changes, right? So those are the things we'll be discussing within this lesson part. So we'll head on to what are the main topics contained in this lesson, right? So let's get some kind of an idea about the main lesson parts that we are going to discuss within this lesson, right? So my dear children, first of all, we'll be discussing about the two main changes that can happen with matter. There are two main changes that can happen to matter, right? So first of all, we'll be gaining some understanding about those two changes that can happen to matter. So the first change is called chemical change. Chemical change. First change is called a chemical change. So we'll be discussing what do you mean by a chemical change, how does the chemical changes are going to occur, and what kind of a thing is going to happen during a chemical change, and several examples related to chemical changes with several experiments. Then we'll be discussing about physical changes. We'll be discussing about physical changes. What sort of a thing is called a physical change? How we can create a physical change in matter? When we are doing what kind of a thing, or what sort of a thing can be done to make a physical change in matter? What are the examples for physical changes? And we'll be observing or will be investigating about several experiments related with the physical changes as well. So that's our first topic, first and foremost chapter. We'll be discussing about the physical changes and the chemical changes. In the second one, or in the next chapter, we'll be discussing about change in state of matter. Change in state of matter, right? So in the earlier part, we have discussed about the matter. I have given you a simple kind of a definition for matter, and you know that I have divided matter into three main categories, three main states as solids, liquids and gases. So in the second chapter, we'll be discussing about how to change, right? How to change these states. How we can turn a solid into a liquid. How we can turn a liquid into a gas. What's the specific term, or what's the special term given for those kind of changes? So like that, we'll be discussing about state changes in our second chapter. So when you are going to learn about these state changes, you may get to know that these changes are actually physical changes. Those are examples for physical changes. Then we'll be discussing about the combustion of substances. You know, in day-to-day life also, you can make fire by combusting materials. So we'll be discussing about what kind of a thing is a combustion is. What are the things which are essential for combustion or to make a fire? How we can put off fire? How we can extinguish fire? So like that, we'll be discussing several things related with the combustion in the third chapter. Then we'll be discussing about corrosion of metals. Corrosion or tarnishing of metals. If you take metals like iron, the most common metal that can be observed in our environment is iron. So iron is a type of metal that we use widely in our constructions, like building constructions, houses, and so on. And you know that when a piece of iron is kept in the environment for about several weeks, it gets a thing called rust. It's a brownish color substance that's going to destroy the surface of the iron, right? So if you take iron is getting rusted. But when you take metals like copper, gold, aluminium, any kind of a metal, all of these metals are going to tarnish over with the time. Especially for iron, we refer that thing as rusting. But if you take commonly for metals, we refer that thing as corrosion or tarnishing. So we'll be discussing what kind of a thing is this tarnishing or rusting, and how does it is going to occur, and what kind of a change is it, and what are the factors necessary or essential for the rusting or the tarnishing of metals. So we'll be discussing these things in our next chapter. Then finally, we'll be discussing about the neutralization. We'll be discussing about neutralization in the next chapter. So neutralization means here we are discussing about the nature of acids and bases. What will happen if you mix an acid with a base? So those things will be discussed under the neutralization part. So stay with me until the end of the lesson to get sound knowledge about these things and to get a sound knowledge about these changes in matter. Right then. So these are the things that we are going to discuss within this lesson. So we'll move on to discuss the first chapter to discuss about what are the things which are called chemical and physical changes. Right. So first of all, we are studying about physical changes and chemical changes that can be happening to matter. So first of all, you are given with a figure. In this figure, you can see there is a piece of paper and you are given with a point, see, tear a paper into small pieces. Now in the first case, here, you need to tear it. You can tear it into several pieces, like in the figure. In the next one, it's given, burn another piece of paper. And now we have to burn it in the second instance. So here in the first instance, you have to tear it into pieces. In the second instance, you have to burn it. Right? So these are the two changes that we are going to do for the same piece of paper. I'm going to take one piece of paper and I'm going to burn it. I'm going to take another piece of paper and I'm going to tear it into small pieces. So you are being asked with a question. Can you explain the difference between these two changes? Can you explain the difference? Dear children, if you take, in the first instance, the tearing process. Even though when I'm going to tear the piece of paper, if you take the composition means the arrangement of materials, arrangement of particles within the paper. That composition or the arrangement of particles is not going to change. If I'm going to assume paper is made up with, if I'm going to assume that paper is made up with A kind of particles. So in a paper there are A particles like this, which are arranged like this way. So this is paper surrounded by particles A. When I'm going to tear it down, even though I'm going to tear it down, these particles are not going to change. If the paper is made up with A particles, then after tearing down, we can observe A particles. There is no change in it. But if you take the structure of it, structure means actually here the size of the particles. So when I'm tearing it down, it's getting separated into smaller pieces like this. Even though it's getting separated into pieces, it's made up with particles A. That's just an assumption, okay? Just an assumption to give you an idea about this tearing process, right? Simple idea is that even though when I'm going to take the piece of paper and when I'm going to tear it down into pieces, just the size of the particle is getting changed or size of the material is getting changed. The composition or how it's been created with is not going to change at all. The particles which is contained within the paper remains the same. It remains the same. If it is made up with A particles like this, then after tearing also we can observe A particles. But the size is somewhat different. That's the only change. Right? Means that we can say that when I'm going to tear the piece of paper, the composition or the arrangement of particles, arrangement of the materials within the matter, arrangement of particles within the matter is not going to change at all. It remains the same. It remains the same. If you are given with a bottle of glue and you are being asked to fix these pieces into get the original one once again, can you do it not or not? Like up to a certain level at least? Of course you can. If you are going to carefully paste each of these smaller pieces, once again we can make this thing not 100% accurately into this one, but up to a certain extent we can fix these things together to create the previous one once again, or the larger piece of paper. So a specialty in tearing process is that even though when I'm going to tear it down, by spending some amount of time up to a certain level, not to 100%, but up to a certain level, I can recreate the original material like this. By pasting, I can originally recreate the previous paper, right? So that's a specialty in tearing process, right? That's the specialty in tearing process. Here, even though when I'm going to tear it down, as long as the materials are remaining same, I can recreate or I can convert it back to the original state once again. So that's the first change which is going to occur for the piece of paper when it is going to tear. What has happened over there? Only the size has got changed. The composition or the materials which is inside the matter haven't got changed at all. Size has got changed slightly, that's it. And this tearing process can be returned to original state or original position up to a certain level. So this is the first change. Now let me take you to the second state or the second change given in here, burning. When you are going to burn a piece of paper, you can observe smoke is going to emit and ash is going to create, right? Smoke is going to emit, ash is going to create as a residue finally. And during the burning process, light and heat energy is going to emit. Sometimes small bit of a sound can also be heard. In this case, you can see that there are several new substances which are getting produced when this change is going to happen for the paper. When I'm going to burn the paper, smoke is coming out. Smoke is a type of a gas. Earlier there was no gases, right? Earlier in the paper there was no any gases. But when I'm going to burn it down, gases are going to evolve. Earlier there was no ash. But when I'm going to burn it down, ash is going to be created during the process, right? So we can say that in the burning process of the paper, the whole composition has got changed in the paper itself to provide or to create new materials. Ash is a new type of a material. Smoke is a new type of a material, right? So this is the second change. And let me ask you another question. If you are given with ash and the smoke which has got emitted, can you turn these things once again back into at least up to a certain extent. Can you change these things once again into a piece of paper like this? Can you? Absolutely you can't. Right? So that's the very specialty in burn-in process. We can't change it back, or we can't revert it back to the original state. If it is burned, then it is burned. Right? New substances have got created. Right? New substances has got created. That's it. And that's the final. We can't revert it back. So my dear children, these are the two main changes which are known as physical and chemical changes there. If a certain material or a certain matter undergoes in a physical change, what change? A physical change. Physical change. Then, in that kind of a case, only if you take the size is going to change. If you take the state, sometimes the state is also going to change. But my dear children, their composition or how the particles are arranged inside the matter, how the atoms are being arranged inside the matter is not going to change. But the size can be changed. Nature of the particle can be changed. Nature means, now if I'm going to take a piece of salt and I'm going to crush it down to smaller pieces. In the earlier case, I got a crystal of salt. Now after crushing it, I have powder of salt. So the nature has got changed. Even though the nature is going to change, their taste is going to remain the same. Right? It's because that both the instances I have got salt. Right? So the nature can be changed. Size of the particle can be changed like this when I'm tearing it down. So physical change is a change like that, where the size is going to change, nature of the particle is going to change, state of the matter is going to change. For an example, for the state change, I'm going to take a piece of ice and I'm going to let it cool. Right? Let it cool. I'm going to take a piece of ice and I'm going to keep it in our environment. It's already in the cool state now, so I'm going to keep it in our environment. Just keep it in our environment, put it into a glass and keep it in our environment. So after some time you can see that ice is going to melt down and liquid water is going to be created within the glass. So that thing is a state change. Even though the ice is going to turn into water, right? Both the instances we can observe water, but in the first instance as ice, in the second instance as liquid or as water. So here a state change has happened. Even though the state changes are going to happen in this thing, right? There is no change within the structure or the composition of the material. Water is water, that's it. So this kind of a change in which the composition of the particles, composition of the materials are not going to change at all is referred as a physical change. It is called as a physical change. A physical change. When I am going to burn this paper down, new substances has got created, change in the composition of the material itself. So this is called as change in the composition to create new materials. This thing is called as a chemical change. It is also referred as a chemical reaction. Chemical change or else a chemical reaction. So the second change is called, I'll write it in here, chemical chemical change. Chemical change or else a reaction. Chemical change or else a chemical reaction. Especially chemical changes are referred as chemical reactions also, right? So these are the two main types of changes that can happen to matter. So my dear children, I have explained what is going to happen in here, right? So let's head on to the lab and we'll see whether we can observe new particles in the burning process or not, and whether we can recreate the original paper or not. So we'll head on to the lab and we'll conduct this small experiment to get some idea about physical changes and the chemical changes. Right, my dear children. Now, let's see how to identify these changes in our environment. So there are like two types of changes which can occur in our environment. So to demonstrate the two types of changes, I have a paper, an A4 sheet, you can see it. So I will take half of this A4 sheet. I'll take half of it. The same A4 sheet, I'm going to take half of it. And this is my one half and this is the other half. Now what I'm going to do is, first of all, I'm going to take this paper, the first half, and I'm going to tear it into smaller pieces like this. Right? Into several smaller pieces like this. See, this is the first one. The first half. I have teared these. I have teared the first piece of the A4 sheet into smaller pieces like this. Right? Then this is the second half of the A4 sheet. The second half. For this half, I'm going to do a certain different thing. I have a spirit lamp with me. So I'm going to light it up. Right? I'm going to light it up. And now what I'm going to do is, I'm going to take this half and I'm going to burn it down. Right. Right, my dear children. The first half, the second half. So when you observe these two instances, it's clear to us that when you take the first half, these ones, these papers are smaller in size. There is no change in composition of the paper. Whatever the material which the paper has made up with, those materials haven't changed. But you can clearly observe the size of the paper has got changed. That's it. Size has been changed. But still, it's a paper. We can write whatever the things we want in these pieces. Even though these are smaller, we can write any of these things. Right? The second half. This half is being destroyed completely due to fire.
means that this is not paper now. The paper has changed into a different kind of a substance. The composition of these substances are not same as these papers right now in the first instance. Right? You can clearly observe even the color has got changed dramatically. Right? Now, if you've been asked to write down certain things on these ashes, can you write it? Of course you can't. Right? And if I'm going to touch these things, you can see here, a small, very small powder has been created. So it's very clear to us that after burning this paper, different substances has been created, and these substances are not same as the previous substances. So I'm going to ask you a simple question once again. Can you take these ashes and convert those ashes into the same paper like this? Even like a small bit of paper like this, so that we can write something? Your answer would be no. By collecting these ashes, we can't convert or we can't create a piece of a paper. It's because that the composition or the materials which contained in these ashes are not same as the paper. All the materials contained inside the paper has got changed now. So it's clear to us that the thing which is happened when I'm going to burn this paper is irreversible, and it is referred as a chemical change. In here, when I'm going to tear the paper down, even though I'm going to make smaller pieces of papers, their composition or how these are being made haven't changed at all. The composition of the paper, composition means the amount and the type of matter contained inside this paper. So it haven't changed, even though the size has been changed. Right? So once again, if I'm going to collect these papers into a correct order, up to a certain level, I can recreate that A4, half of that A4 sheet. Up to a certain level, not to 100%, but to up to a certain level, I can recreate the A4 sheet. It's because that the thing which is happened in here is a physical change. Just the physical nature or how the particles are being, how the substance or way of the substance, the nature of the substance has got changed. That's it. The composition or the nature of the particles haven't got changed in this occasion. Right? So therefore, it's clear to us that this is a physical change from larger material to smaller materials are being created here, but in here, by destroying all the materials or all the paper contained earlier, new substances, ash, being created. So these are the two main types of changes that we can observe in the environment. In the first one, just only the physical change. In the second one, the chemical changes. So we'll observe somewhat different things rather than these burning things. Burning of paper rather than the burning the paper, we'll observe some different things or different activities, different experiments to observe what sort of a thing is a chemical change and what sort of a thing is a physical change. So let's carry out some different activities to identify those examples as well.
Right, my dear children. So as I explained, you could observe when I'm doing the experiment, when I'm burning this thing down, when I'm tearing it down, you could observe that. Right? During the burning process, new substances are going to create, and when I'm going to tear it down, there is no difference or there is no change in the composition. The same material, the same piece of paper is going to be there and there is no change in it, right? So these are the two main changes that we can observe in matter. So those two changes are physical changes and the chemical changes, right? So we'll move on with the next slide to get some sound idea about physical and chemical changes, right? So here you are given with the explanation once again. Though the paper is torn into pieces, it is still a paper, right? You know that it is still a paper. Even though I'm going to tear it down, still it is a paper, right? Only the size is getting changed. So when tearing a paper, its composition is not subjected to any change. So the composition, arrangement of particles or the composition is not going to change at all, right? Something which is not a paper cannot be formed by tearing the paper, right? So something which is not a paper cannot be created by tearing the paper. When I'm going to tear the paper, new substances are not going to create. It is still the paper. By tearing the paper down, I can't create new substances, right? Therefore, such changes are known as physical changes. So, in a physical change, my dear children, new substances are not getting created. The original substance remains the same. I can't recreate new substances during a physical change. And the other thing is that if you take a physical change, the composition or the arrangement of particles, arrangement of atoms, arrangement of matter remains the same. It remains the same. So that is about the physical changes then. Physical changes. Then, in the second one, once again see. However, when the paper is burnt, ash and smoke are formed. So here I told you earlier also, ash and smoke are two new substances came out from the paper during the process of burning, right? So here we can say that new substances has got created during the burning process. So there the composition of the paper changed and new substances. So there the composition of the paper changed and new substances are formed. Such changes are known as chemical changes. So these type of changes which the new substance are going to create by changing the original composition, original arrangement of the particles are referred as chemical changes. These changes are referred as chemical changes. So physical changes and the chemical changes. These are the two main changes that can occur into a substance or else a matter. Once again, my dear children, in a physical change, no new substances are going to create at all. Original or the initial substances remains the same. Physical change. In a chemical change, new substances are going to create by the original substance. New ones are going to create, like creation of ash and smoke during the burning of paper. So these are the two main changes that can happen into matter. Other specialty in these two changes is that physical changes can be reverted back to original state up to a certain level, my dear children. Not 100%, I can't, not 100%. I mean, like if you're given with a paper, if you tear it down, I can't recreate the paper 100%. But up to a certain level, you can. Right? But if you take a chemical change, there's no possibility. We can't recreate it at all by using those leftover substances. If you are given with smoke and ash, we can't recreate the paper. So therefore, in chemical changes, there is no reverting back. But in physical change, yes, we can. So that's another specialty in physical and chemical changes. So my dear children, these are the two main changes that can happen into matter: physical changes and the chemical changes. In a physical change, composition remains the same, arrangement of the particles remains the same. There is no creation of new particles or new materials. In a chemical change, arrangement of the particles are going to change, composition of the material is going to change, and new substances are getting created. In a physical change, we can revert it back to the original state. In a chemical change, we can't revert it back to the original state. So I hope you got a good idea about what are these physical and chemical changes. Right. Then we'll move on to the next slide to observe what are the other contents in our lesson. Right, my dear children, once again you are given with the explanation for physical and chemical changes. So, chemical change, changes in which the composition of matter forming new substances are known as chemical changes. Right? Physical changes, changes in which the composition of matter does not change even though its nature of existence changes, are called as physical changes. Right? So, in a physical change, composition of matter, in a physical change, composition of matter does not change. Composition of matter does not change. But in chemical changes, composition of matter changes. Right? Composition of matter is going to change. So this is the main difference between the physical and the chemical change. Okay. So you are given with an activity in here. You are given with an activity, right? So we'll be getting some sound idea about physical and chemical changes in this part, right? So to get a certain or else a good idea, here you are given with an activity. So we are studying about the nature of physical changes mainly in here. We're going to study about the nature of the physical changes, right? So to get some idea about the nature of physical changes, let's see how to conduct this activity and what are the materials we need. So first of all, you'll be needing a beaker, right? It's okay to have a beaker, a smaller bit of a one, or else a boiling tube is also fine, no problem at all, right? Here we are going to heat a certain substance, right? So therefore, beaker that can be heated up to a certain extent. If you don't find out, or if you can't find out a beaker, then you can get a boiling tube also, no problem. Then we'll be needing water, salt. We'll be needing salt, right? This is the next one, salt. Small bit of salt to add with water and to heat up. Then tripod. You know that tripod is important to place these materials or place that beaker upon the Bunsen or the spirit lamp burner, right? So next one, we'll be needing spirit lamp. or else a Bunsen burner. So these are the materials that you need, my dear children, when conducting this activity. What are those materials? You'll be needing a beaker or else a boiling tube to heat the substance. You'll be needing some amount of water, salt, a tripod, spirit lamp or else a Bunsen burner, right? Spirit lamp or else a Bunsen burner. So let's see how to conduct this activity then. So here what we are going to do is we are going to add some salt into water and we are going to dissolve it very well. So when you are dissolving salt in water, salt is going to disappear. There is no salt in it. You could observe, you could have observed these things at your home as well, right? When your mother is cooking meals, you know that she's going to add salt. Even though we can feel the salty taste in food, there is no salt in it because salt is going to dissolve within the curries or whatever the materials. So here also we are adding salt into water. When adding salt into water, salt is going to disappear or it's going to dissolve. Now there's a certain change has happened. There's no salt in it, right? Salt has disappeared and it has got dissolved in the water and there is no salt further, right? So I'm going to show you that we can recreate salt once again. Why we can recreate the salt once again within the container? How come we could recreate salt once again within the container even though it's been dissolved? It's because that here the salt is undergoing in a physical change. Not a chemical change, but a physical change. That's why even after dissolving salt in water, we can recreate salt by doing a certain process. So I'm about to explain what that process is. So let's see how to dissolve salt in water and how to recreate salt out of that solution. Right, so let's see how to conduct the method. So first of all, we need to dissolve salt and make a salt solution. Dissolve salt in the beaker and make a solution. So we need to first of all dissolve salt in the beaker and make a solution. We have to make a solution. Then place the solution on the tripod place the lamp below the tripod and heat the system well. Heat the system well. Then in the next one, boil and evaporate water. Right, so this is the method of doing this experiment. First of all, dissolve salt in the beaker and make a solution. You have to dissolve salt and make a solution. Place the solution on the tripod. Place the lamp below the tripod and heat the system well. We have to place the beaker on the tripod and spirit lamp or the whatever the lamp that you are going to take, can be a Bunsen burner also. You have to place it underneath the beaker and we have to heat it. Then after that, finally boil and evaporate water. We have to boil water and evaporate all of it, right? So you can draw and show a figure like this. So this is the tripod. Okay, then you place the beaker like this, water. Then we have to place the lamp like this. Then we have to heat it up, right? So this is the beaker with salt, solution, beaker with salt solution. Then this is the tripod. And this is the lamp. It's really simple. Yeah, so you have to heat it and evaporate all the water, and now you have to observe what is going to happen. Right, so this is the way of conducting the activity, my dear children. So first of all, you have to dissolve salt in it and we have to heat it until the water is going to evaporate. Right, so let's see what is going to happen in here. What kind of a thing is going to remain within the system after evaporating water? So we'll head on to the lab and we'll conduct the activity and let's see what are our observations and conclusions. Right, my dear children, now we are about to investigate another experiment. So in this experiment, I'm going to use some salt and dissolve it in water, and by heating I'm going to evaporate all the water in it. Okay, so by that way I'm going to observe whether this change which occurring inside the salt solution is a chemical change or else a physical change, right? So I have salt with me. In this petri dish you can observe the salt. So salt, it has a white color structure, white color nature, somewhat white color, and it is in crystalline nature. Crystalline means it's like powder. See, small powdered crystal. So now I'm going to take small amount of salt and put into the beaker like this, and now I am going to add 50 milliliters of water to the beaker. So let's add water. And I'm going to take the glass rod and stir it very well to dissolve all salt in it. So when I'm dissolving salt, gradually the salt crystals will dissolve in water
and the crystalline nature or the salt will totally disappear, right? It will totally disappear. So you can clearly see that in here, right? So I'll mix somewhat, right? So my dear children, you can clearly observe that there is no salt in it. All the salt have been now dissolved inside the water container or the water beaker which I have right now. Some of you may think, now salt has been disappeared. No, means that this is a chemical change. But what happens if I'm going to heat this container and vaporize all the water in it? Can we observe the salt once again? So let's conduct the activity and we'll see whether we can get the salt which we dissolved inside the beaker after vaporizing the water. So now what I'm going to do is I'm going to use this tripod and place it on the Bunsen burner like this. This is the Bunsen burner and the steel mesh to hold the beaker. Now I'm going to light up the Bunsen burner and I'm going to heat it down. Right. So now I am heating the beaker very well. So let's observe what will happen in the end when I am heating it. So we'll take somewhat time because we need to evaporate all the water in the beaker in order to observe or in order to get our necessary observations. So be patient and observe what will happen to the beaker when vaporizing the water. Right, my dear children, now see the beaker is gradually heating up. And if you observe clearly, you can see there are some small bit of like powder is like dust or a powder is getting deposited at the bottom, right? If you could observe, you can see like there is a powder which is going to the bottom of the beaker. Very small drops or very small powder like thing is depositing at the bottom, right? Observe very clearly. You can see even in this area, you can observe that white color powder. So let's give it somewhat more time so that the water will evaporate completely and we'll observe what will happen at the end of the experiment, right? So we'll give it somewhat more time to evaporate water. Right, my dear children, now we are at the final stage. Now almost all the water has been evaporated. Now we can clearly observe those white powder around the beaker, right? See, if you check the wall of the beaker, you can clearly observe that white color powder. So that white color powder is the salt that we dissolved in the earlier stage, right? So in here, even though we have dissolved salt in water, when heating, we can get the amount of salt which was dissolved earlier in the same stage as powder, right? Now if you measure the amount of mass, you can get the same amount of salt which was dissolved in the earlier stage. Now it's because that when dissolving salt in water, the nature of the substance or the composition of the substance, composition of the salt is not getting changed. Salt is chemically referred as sodium chloride. Means that it contains sodium and chlorine. So sodium chloride or salt, the composition of salt or composition of sodium chloride is not getting changed when this thing is going to dissolve inside water. So when vaporized in water, we can observe at the bottom the precipitation of salt. So here once again the salt has been precipitated. So we can observe at the end the salt crystals. Right, my dear children, now I have vaporized all the water in the beaker. So at the bottom, see, you can observe the salt, right? So I'm going to use this crucible. I'm going to show it to you how the salt has been deposited inside the beaker. See, all the salt that we dissolved in the initial stage once again can be observed at the bottom of the beaker. It's because that this dissolving process, dissolving salt or sodium chloride, is just a physical change. The salt crystals or salt powder, I have dissolved it in water. Even though I am going to dissolve it, right? See, even though I am going to dissolve it, their physical nature is going to change, and that's it. So their chemical structure or the composition of the material is not going to change at all. So therefore, that's why we can get all the salt once again back to the beaker when I'm going to vaporize the water. So it's clear to us that dissolving salt in water is just a physical change. Here the salt crystals is going to dissolve inside the water to make a salt solution. So when I'm vaporizing water, I can revert the process once again to obtain salt powder, right? So dissolving salt in water is a physical change. So we'll observe what are the other examples. What are the other examples that we can observe in our day-to-day life to get some idea about physical and chemical changes? Right. So let's proceed to the next things.
Right, my dear children. So you could observe that when I'm doing the activity, you could observe that when all water is going to evaporate, the salt which I was initially dissolved in the system remained in the beaker. It retained within the beaker, right? I could find salt finally at the bottom of the beaker, right? So that observation was very clear to us. Even though salt has got dissolved in water, when I'm going to vaporize water, right? When I'm going to vaporize water, when I'm going to remove water, salt retained in the beaker in the same state where it was initially was. It's because that within this change, the salt has undergone a physical change, right? Salt has undergone a physical change. So we can write our observation. What is our observation? Salt remained salt was left in the system. Salt was left in the system after evaporating water. So this is our observation, right? Water has got evaporated and salt retained, or salt was left in the system. So salt was left in the system after evaporating water. So what is the conclusion that we can take from this activity? Our conclusion is that when dissolving salt in water, right, or if you dissolve something in water like salt, sugar, glucose, that kind of a thing, or that sort of a chemical, that sort of a change is not a chemical change, but it is a physical change. That's why we can revert it back to the original state, right? So dissolving salt in water can be considered as a physical change, physical state change. Here we can say that salt is going to dissolve within water, and when I'm going to evaporate water, once again salt is going to remain, right? So dissolving salt in water is a type of a physical change. It's type of a physical change. So we can finally conclude that it is a physical change because there is no change in the nature of salt. That's why original salt was once again created when I'm going to evaporate water. So finally we can conclude this activity reflects a physical change. So dissolving salt in water is a type of a physical change. It's a type of a physical change, my dear children. So this is the final conclusion that we can take from the experiment, right? So you can see that if you take a physical change, physical changes can be reverted back, right? In a physical change, only the nature of existence in particles, I mean the nature of matter, is going to change. New substances are not getting created, right? New substances are not getting created. As new substances are not getting created, these substances remain the same. Original substances can be obtained once again after a physical change, right? So this is the nature of physical changes, my dear children, then. So we'll head on to see our next slide, and let's see what are the other contents. So in the next slide, we are going to examine about chemical changes, right? So here we are going to study the nature of chemical changes. So let's see what kind of a thing is going to occur in a chemical change by conducting this small bit of an experiment. So first of all, you'll be needing these materials in conducting this activity. This is a roll of magnesium. Magnesium is a metal, right? It doesn't have a shiny surface. Magnesium is somewhat strongly reactive with the oxygen in our environment. So there is a layer of oxide. You'll get to know what do you mean by an oxide layer when I'm doing the lesson part tarnishing of metals. Just now you remember there is a layer of oxygen, right? There is a layer of oxygen around the magnesium, and there is no shiny layer, there is no shiny surface due to that. You know that every metal has some kind of a metallic luster. But magnesium, when you take fresh magnesium piece, it has a luster, but when it is being kept for a longer time period in our environment, there is no luster in it. So when you are going to take magnesium for a certain experiment, first of all, you have to scratch it very well by using a sandpaper. And we have to remove that oxide layer. When you are going to scratch the piece of magnesium, then you can observe that metallic luster of magnesium very well, right? So remember, my dear children, when you are conducting activities or experiments with magnesium, first of all, you have to remove that oxide layer, that brown color layer, not the ash color layer on the top of the metal, right? There is a small bit of a ash color layer, so we have to remove it. So when you are removing that layer, shiny surface or the shiny nature would come. So you will be needing that kind of a cleaned magnesium piece. Okay, cleaned piece of magnesium. You have to clean it by using a sandpaper. You can clean it by using a sandpaper. So you'll be needing a piece of magnesium, cleaned, piece of magnesium. Cleaned piece of magnesium, then spirit lamp. Spirit lamp. So these are the two materials you need. It's really simple, right? And sometimes now it's hard to place this magnesium piece over the spirit lamp, no. So therefore you can use a forceps, right? You can use a pair of forceps in order to hold this magnesium stripe or the magnesium piece. Okay, definitely you will be needing a forceps too, otherwise you can't heat it, you can't burn it. So therefore we need to have a forceps as well, right? So these are the two main materials you need. To hold that, we need that forceps thing. Okay, right? So let's see how to conduct the activity. So method is really simple, my dear children. What you have to do? Take the piece of magnesium and hold it over the flame of spirit lamp, and we have to burn it down. Okay, so it's really simple. Then we have to observe what kind of a thing is going to occur and what sort of a thing is going to happen during the experiment. You have to record the observations very well. So it's really simple. Method is really simple. We have to place the magnesium stripe over the flame and we have to burn it. So can write, place the magnesium piece, over the flame of the lamp, and burn it. Observe the change. Observe the changes. the changes happen. Observe the changes happen to the piece of magnesium. Right. So this is what you have to do within this experiment. Place the magnesium piece over the flame of the lamp and burn it. Okay. Then observe the changes happen to the piece of magnesium, and we have to record it. Okay. So this is the way of doing our experiment. So we'll head on to the lab and we'll conduct our experiment, and let's see what is going to happen when I'm going to burn the piece of magnesium.
Right, my dear children. Now, this is the next activity to observe or to get some idea about physical and chemical changes. So I have a metallic ribbon. See? This is magnesium. This ribbon is called as magnesium. So it doesn't have, even though it is a metal, you can see that it doesn't have any kind of a luster. Luster means there is no shiny surface, right? You can see it. It's because that magnesium is covered by an oxide layer. Magnesium is going to bond with oxygen in our nature or in our atmosphere, and an oxide layer can be observed around magnesium. So when you are using magnesium for an experiment, you have to, like, by using a small bit of a sandpaper, you have to like scratch it. So when you scratch it very well like this, right, you can get the metallic luster of magnesium once again. But magnesium is highly reactive. See, you can observe the shiny surface. But the thing is that magnesium is highly reactive. Reactive means it's going to bond with oxygen quite fast. So when I'm going to keep this thing of the magnesium stripe in our normal environment for 1 or 2 or 3 days, the shine of the luster of the magnesium will once again reduced, and this ash color oxide layer can be observed. So I have some magnesium stripes which I already scratched by using the sandpaper. Now what I'm going to do is, by using this crucible and my spirit lamp, I'm going to burn this piece of magnesium to observe what has happened or what kind of a thing is going to happen after burning a piece of magnesium stripe. So let's see whether this thing is a physical change or else a chemical change. So let's burn the piece of magnesium to observe whether this is a physical or else a chemical change. Right, my dear children, observe. So I'll use this petri dish to put the waste. I'll use another one. I'll use another piece and I'll burn it. See the color? Let's try another one and let's see what are our residues. Right, my dear children, now you have observed what is going to happen when you burn a piece of magnesium like this. So let's see whether that hard nature of magnesium, now when you take this magnesium piece, now this is a magnesium piece which I have prepared. It's not like a powder. You can observe it clearly. It's not like a powder. It's hard, right? See this thing. Now this is the residue or the remainder after the burning process of magnesium. See, it's getting into a powder. It's getting into a powder. See, it's a white color powder right now, right? It's a white color brittle powder. Brittle means breaking down quite easily. So here you can observe that, see, you can observe the white color very well. So this white color powder is referred as magnesium oxide, because during the burning process, magnesium is joining with oxygen, or it's burning with oxygen. You know that in your previous grades you observed, or you know that during a burning process, or when something is burning, oxygen is very important, right? So when you burn something, when you burn anything, that material is going to bond or react with oxygen gas, and the nature or the chemical structure, the composition of the material is getting dramatically changed. It's changing into a different form. So in the earlier part, we burned a paper, and I told you that that's a chemical change. Now here also you can see a white color powder. So burning a piece of magnesium is a good example for a chemical change, right? So these chemical changes are also referred as chemical reactions. Here the magnesium has reacted with oxygen gas to produce this white color magnesium oxide powder. So burning a piece of magnesium is a good example for a chemical change or else a chemical reaction. You can't invert or you can't change this powder into once again piece of a magnesium stripe. It's because that these chemical reactions or these chemical changes cannot be reverted back to original position or to original stage. So we'll carry out some other experiments in order to get some idea about these physical and chemical changes.
Right, my dear children. So when I'm burning the piece of magnesium, you could observe that a bright white color flame is going to emit. It's very difficult to see that thing even. A very bright white color flame is going to emit. And some amount of smoke is also going to emit from the system. And finally, if you take the residue, that leftover part, it's a white color powder, dust like a powder. You could observe that thing, right? So I think you have observed the experiment very well. So those are the three main observations that we can take. Number one, magnesium is going to emit, or magnesium is burning with a bright white color flame. A smoke is going to emit. And the residue means the leftover part after the change, right? So the residue has a white color powder. These are the three main observations that we can take from the experiment. So we'll write down those three observations, my dear children. So the first observation, number one, bright white flame is given. Bright white flame is given. This is the first observation. Number 2. Smoke emits. Smoke emits, right? Smoke emits. Number 3, third one. White powder is remained. White powder is remained. White powder is produced. Produced as a residue. Right. So these are our 3 observations from the activity. Number 1, bright white flame is given. Number 2, smoke emits. And number 3, white powder is produced as a residue. Residue means that leftover. After the process, whatever the thing which is left over within the system is called the residue. Right, my dear children. Now, see what has happened to the piece of magnesium. There is no magnesium right now. Magnesium has got changed into several substances. A white color powder, smoke, a bright flame. So here you can see that by changing the structure of magnesium, all new substances have got created from this change. So we can say that burning that piece of magnesium is a wonderful example for a chemical change or else a chemical reaction, because in each of these steps you could see that, right, new substances has got created. There is no magnesium right now. This white color powder is called magnesium oxide. It's called as magnesium oxide. This magnesium oxide is a substance that create when reacting or when oxygen is going to act with magnesium. You know that when you are burning something, in the earlier grades also you observed this thing. To burn something we need oxygen gas. Burning means reacting or interacting with oxygen gas. So when magnesium is going to interact with oxygen gas in our atmosphere, magnesium is going to convert into a certain type of a substance that has a white powder. There is a white powder which is called as magnesium oxide. Magnesium is turning into magnesium oxide. Magnesium is going to join with oxygen to produce new substances, the magnesium oxide. Earlier it was just magnesium. There is only magnesium atoms or magnesium material contained within the piece of magnesium. After when I am going to burn it, when I am burning it down, magnesium is now bonding with oxygen to recreate a new substance called magnesium oxide. So that magnesium oxide is far more different than magnesium. That's why it's creating a white color powder. So my dear children, it's obvious to us that here the chemical composition or the chemical structure has got changed. Arrangement of the particles has got changed. Composition of the material has got changed. And new substances were created. So therefore, this is a good example for a chemical change. So finally we can conclude that new substances new substances are created when burning magnesium. So new substances are created when burning magnesium. So therefore, finally we can say that burning magnesium is a chemical change. So new substances are created when burning magnesium. So burning magnesium is a chemical change. This is the final conclusion that we can take. How you can say that new substances has got created? By using these observations. It is giving out a bright white color flame. Earlier there was no such observation, right? And it can be observed that a smoke is going to emit a new substance. Smoke is a type of a gas. In the earlier there was a solid. White color powder. White powder is produced as a residue. All of these substances are new, right? So therefore we can say that new substances has created from this reaction or from this change. So thereby we can say that finally burning of magnesium is a chemical change, my dear children, right? So this is the nature, or this is how we can identify a chemical change, right? So physical change, chemical change. This is the nature. So we conducted 2 experiments to identify or to get some idea about physical and chemical changes. So I hope that you got a sound knowledge about physical and chemical changes, my dear children. So let's move on with the next slide to observe our other content. Right. So here the changes we experience in our day-to-day life can be divided into 2 types: physical changes and chemical changes. So we conducted 2 different experiments and we discussed about the nature of physical changes and about the nature of chemical changes. How or what kind of a thing is a physical change, what sort of a thing is going to happen in a physical change, and what kind of a change is going to happen in a chemical change, right? With two distinctive experiments we discussed those things, right? And we took the observations related with the experiments also. So we have identified what do you mean by a physical and what is a chemical change. So in day-to-day life also materials are going to undergo in these 2 changes, right? So those 2 changes are physical changes and the chemical changes. So engage in given assignment to reinforce your knowledge about this regard. So you are given with an assignment here. So what is this assignment, my dear children? Classify the following changes as physical changes and chemical changes. So here you have to classify these given examples as chemical changes and physical changes, right? So we'll do this assignment, okay? And at home you get several changes and see whether new substances are getting created or not. And by that way, classify those changes into physical changes and chemical changes. So I'll do this thing. I'll divide these things into physical and chemical, right? You find out several examples at home and try to divide them into physical and chemical changes, right? So let's divide these things now. So I'll take it here so that I can draw a table. Right, let's draw a table. Right, so within the table I'm going to include physical, changes, then chemical. Physical changes, chemical changes. Now we'll write down. Number 1, melting of solid wax. Melting. Melting means you are turning a solid substance into a liquid substance. Solid is getting changed to liquid, like ice is getting turned into liquid water. Right? I took that example when I was starting the lesson. I think you could remember it. Ice is turning into liquid water. State is going to change. No matter the state is going to change, their structure, new substances are not getting created over there. Only the physical state is getting changed. Solid to liquid. That's it. So there are no new substances. Even though when I'm going to melt wax and turn it into a liquid, that liquid is wax, no? That liquid is not water, it's wax. So therefore, melting of solid wax is a type of a physical change. Here the physical state, solid state, is getting converted into liquid state. That's it. Right. So number 1 we can write melting of solid wax. Melting of solid wax. Right, melting of solid wax. First one. Okay. Then the second one. Here once again you are given with melting of ice. The earlier example which I took to explain about the physical change, I think you could remember it. Okay. Melting of ice. So during the melting of ice also, solid is getting changed into a liquid. No new substances are getting created. So second one, this thing, melting of ice. So melting of ice is also a type of a physical change. Type of a physical change. Next one, burning firewood. Burning firewood, my dear children. What happens when you burn firewood? A smoke is going to emit. A yellow color flame or yellow or red color flame is going to emit. Charcoal is going to create. Ash is going to create. Right? So here you can see that. Like in the earlier case, when I'm going to burn piece of magnesium, new substances are getting created during this change. Right? New substances are getting created. That solid firewood is going to convert into a gas and emit smoke. A flame is going to emit. And once again, charcoal and ash is found as a residue. We can't convert these things back to firewood once again. So therefore, there is no reversing back of this change. So you can see clearly this change is a chemical change as it is creating new substances, right? So we can write burning of firewood, right? Burning of firewood So burning of firewood is a chemical change. Next one, vaporization of water. Vaporization of water. I think you could remember the experiment that we took to discuss the nature of physical changes, where we dissolve salt in water and we vaporize water. We vaporize water to retain salt. During the process of vaporization, my dear children, liquid water is getting changed into a gas. Water vapor or steam is a type of a gas. Once again, here you can observe a state change. Once again, you can observe at that occasion a state change. A state change means, in that case, liquid water is getting converted into gaseous water vapor. Even though liquid water is getting changed into gaseous water vapor, the structure of the material remains the same. Arrangement of the particles remains the same. Composition of the material is the same. So therefore, there are no new substances which are getting created. Only their state of nature is getting changed. Liquid is getting converted to a gas. That's it. So therefore, vaporization of water, my dear children, is a good example for a physical change. Vaporization of water. Right. Vaporization of water. Right. Vaporization of water. Next one. Breaking granite into pieces. Breaking granite into pieces are a very common example for a physical change. I think you would remember in the earlier part when we are discussing about those physical and chemical changes, I took a piece of salt as an example. Piece of salt crushing into small pieces to make powder. Only the size is getting changed. When changing the size, right, no new substance are going to create. Original substances remains the same, but only the size is getting changed. So it's a good example for a physical change. So breaking granite into pieces, physical change. Breaking granite into pieces. This is a good example for a physical change. Size of the material is getting changed. That's it. Right? Larger pieces of granite is converted into smaller pieces. Next one. Lightning a cracker. Lightning a firecracker. If you take lightning a firecracker, when you light up a firecracker, what happens? Giving out a huge sound and it's going to explode. Light energy is going to emit. Smoke is going to emit. Sparks are going to come out. Obviously then, new substances are getting created in this process. Smoke, a new substance. That sound which is going to emit, a new thing. Right? Sparks, a new thing. So all of these things are new substances when you are going to light up a firecracker. So after lighting up a firecracker, by collecting those things, we can't recreate the firecracker also. Means that this change cannot be reverted back. So it's obvious to us that this is a chemical change. So my dear children, lightning a cracker is a chemical change. Lightning cracker. Lightning a cracker is a chemical change. Next one, rusting of iron. During the process of rusting of iron, right, the thing is that iron is going to change the physical nature. The nature of the iron, lustrous nature of the iron is going to change. A brown color substance is going to create on the surface of iron. And if you keep that thing for a very longer time period, right, like month or two, right, like year or two, in that case, the whole iron will break down into very small pieces, right? And the thing is that, my dear children, by collecting those pieces, small pieces, I can't recreate the piece of iron which was originally placed, right? And after the rusting process is going to end, the iron is going to destroy. Means that we can't reuse iron. Iron is going to convert into a brittle substance. It's going to break down very quickly. So when instruments are getting rusted very quickly, we have to remove it. We can't reuse it. If you take a knife, if it has rust, then we have to remove it, my dear children. We can't use it. It's not hard. If you are going to bend it like this, it's going to break into several pieces. It's because the physical structure as well as the chemical nature or the composition of the material has got changed here, right? That's why the hardness is going to be fade off from the material. Now, when you take the hardness, iron is a good hard substance, but when after catching up with rust, iron is going to convert into a brittle substance. It's going to break into very small pieces. Even you can crush it like this if it has rust. It's because new substances are getting created. Iron rust is a very new substance. By collecting iron rust, we can't recreate iron. So therefore, it's a good example for a chemical change. So rusting of iron is a chemical change. Rusting of iron. Rusting of iron. Then the next one, burning of camphor. Once again, camphor balls are going to burn by emit a smoke, and a flame is also going to emit. Some kind of a smell is going to be felt. So you have seen it. I think you have burned up several camphor balls at your home also. So burning process, like in the magnesium thing, it's a good example for a chemical change. So burning of camphor is a chemical change. Burning of camphor. Right. So these are the answers, my dear children, for the division process in here. So we'll separate these things. Right. So these are chemical and physical changes. Examples for chemical changes and example for physical changes. So here you can observe during a state change, like solid is getting converted into a liquid, like ice is getting converted into liquid water, like vaporization of water where liquid water is getting converted into a gas. In these instances, state changes, especially, all of state changes are considered as physical changes. So it's easy to identify physical changes. If it has a state change, definitely it is a physical change. See, melting, then vaporization, those sort of stuff where the state is going to change, those things are physical changes. If it is burning to create new substances like smoke and a flame, right? Like if the nature of the substance is going to change, like the hardness, ductility, malleability, if like those factors are going to change, like in rusting of iron, right? And if new substances are getting created by giving out a flame, like and by giving out a smoke, by creating a special kind of a residue, in that process, in those instances, new substances has got created. So if new substances are going to create, like in these instances, we can observe a chemical change. So this is how to classify chemical changes and physical changes. So I hope that you also took a good knowledge about physical changes and chemical changes, my dear children. So in our next chapter, we'll discuss further things related with the lesson.